Alright, this is going to be Chapter 4, Understanding EKGs and the Electrical Conduction System. Objectives of this chapter are going to be to identify the location of the following: SA node, sinoatrial node, internodal pathways, Bachmann's bundle, AV node, bundle of His, the AV junction, the bundle branches, the Purkinje network. Relate the normal pathway of an impulse traveling through the electrical conduction system. And we're going to start this off by talking about the conduction system. The sinoatrial node is the primary pacemaker of the heart. It's located here. The AV node is what would take the electrical stimulus through the ventricles. And then you have these internodal pathways that are here and here. So how this works is that these pacemaker cells fire off an action potential that gets moved through the myocardium of the atria and the ventricles. The sinoatrial node fires it off, and it's spread across the atria and allows the atria to contract simultaneously. When this waveform then hits the AV node then takes up the time, or takes up the stimulus, and transmits it to the ventricles. And the bundle of His, located here, is a large bundle of fibers that are going to transmit the information into the left and right bundle branches. And this here is the interventricular septum, which kind of sheaths or houses the left and right bundle branches. The right bundle branch is located here, and the left bundle branch is located here. Now down here at the bottom at the Purkinje system, all these little fibers is what transmits the electrical stimulus into the myocardial tissue. So again, back up to the top, sinoatrial node fires. Travels across the atria, simultaneously contracting the atria. The wave then hits the AV node then fires, transmitting the electrical stimulus into the left and right bundle branches. As this travels down to the apex, nothing starts contracting until it hits this spot in the heart. At this spot, the electrical stimulus turns and gets transmitted into the myocardial tissue to where it starts the contraction. This place being first, so the atria will contract in this direction, and the ventricles will contract in this direction. The sinoatrial node, located in the upper posterior area of the right atrial wall of the heart. 50% actual pacemaker cells. The remaining cells conduct electrical impulses. It is the primary pacemaker of the heart, and the firing rate, or the intrinsic rate, is 60 to 100 beats per minute. Depolarization of the myocardial contractions occur after impulse leaves the sinoatrial node. Internodal pathways, receiving the electrical impulse as it exits the sinoatrial node, and this is what will transmit it across to the atrial area. Pathways distribute impulses through the atria and transmit the impulses from the sinoatrial node to the atrioventricular node. Bachmann's bundle, also known as Winky-Bach's bundle and Thorell's pathway, a group of interatrial fibers contained in the left atrium. Subdivision of the anterior internodal tract conducts electrical stimulus from the sinoatrial node to the left atrium, and this is what's going to allow for whenever it fires in the sinoatrial node to maneuver or put the electrical stimulus over into the left atrial area. The AV node, atrioventricular node, or AV node, located on the floor of the right atrium above the tricuspid valve. Electrical activity delay is about 0.05 seconds, allows for more complete filling of the ventricles. Only pathway of the atrial electrical impulses to the ventricles. Now, the SA node fires, it transmits it across to the atria contracts simultaneously, the waveform then hits the AV node then transmits it to the ventricles, and the ventricles will fire retrograde or in the reverse direction of the atria. The AV junction. SA node joins the bundle of His. If the SA node fails or slows below the normal rate, AV junctional tissues initiate the electrical activity and thus the role of the secondary pacemaker. Accessory pathway, an irregular muscle connection between atria and ventricles that bypasses the AV node. The bundle of His. The bundle of His, conduction pathway that leads out of the AV node, receives blood from the left anterior and posterior descending coronary arteries, lies on top of the interventricular septum, and referred to as the common bundle, the bundle of His. This bundle here is just below the AV node, and this is a very large bundle of fibers that are the pacemaker cells. If the AV node fails, we can generate an impulse beat from the bundle of His. The bundle of His ability to self-initiate electrical activity at an intrinsic firing rate of 40 to 60 beats per minute. Connection between the upper and lower chambers of the heart, and this is what's going to connect the atria, both of them, from the ventricles. The bundle branches. The bundle of His divides into two main bundle branches, a right bundle branch and a left bundle branch. And the bundle branches conduct electrical activity from the bundle of His, just below the AV node, to the Purkinje network. Now, if you'll remember in our first illustration, that the Purkinje network is the actual fibers that are touching the myocardial tissue itself. So whenever the stimulus gets to the Purkinje network, this will transmit the electrical impulses to the myocardial tissue and cause contraction in the Purkinje network. Fibers that spread throughout the ventricles carries impulses directly to the ventricular muscle cells, an intrinsic firing rate of 20 to 40 beats per minute. Review of the electrical conduction system of the heart. The SA nodal firing rate, and these are all important numbers to remember, is 60 to 100 beats per minute. The internodal pathways, pretty much their job is to transmit the electrical stimulus to the atria simultaneously, so that both atria contract at the same time. Next on the list is the AV node, or the AV junction, and the bundle. Its intrinsic rate is 40 to 60 beats per minute. So if you see something that later on we'll identify that has no P wave, or an inverted P wave, and it's running 40 to 60 beats per minute, this would be a junctional rhythm or an AV nodal rhythm. The bundle branches separate the electrical stimulus into left and right sides and allow it to continue on to the Purkinje network. The Purkinje network spreads the electrical stimulus to the actual ventricular muscle itself. It has an intrinsic rate as well that is 20 to 40 beats per minute. So I cannot express how important it is at this point to identify the intrinsic rates of each one of these sites. So again, SA nodal rate 60 to 100 beats per minute, AV nodal rate 40 to 60 beats per minute, and Purkinje network or ventricular muscle rate at 20 to 40 beats per minute. An overall review of the electrical system here. Starting with this illustration here, which is A, you have the sinoatrial node, you have interatrial pathways that are spreading it across the atria, you have the AV node, right bundle branch, left bundle branch, and then this down here is the Purkinje network. Alright, so starting at the top right here, SA node fires, spreads a contraction wave across both atria, which allows the atria to contract simultaneously. This takes what blood is in there and pushes it into the ventricles. The AV node then fires, moves the electrical stimulus to the apex of the heart. Nothing happens on the contraction yet. Whenever it starts to get into the Purkinje network itself, the Purkinje network then starts contracting the muscle tissue. This is what's going to push the blood up, closing the AV valves, which are located here. Once those valves are closed, pressure continues to build. It's going to pop open at that point the pulmonic valve and the aortic valve simultaneously. Pulmonic valve pushing it into the pulmonary trunk to get oxygenated, and the aortic valve pushing it out to the body. And that will be the end of Chapter 4, AV, or the conduction system.